Hello champions, welcome to my math class. I'm teacher Adam and we are going to continue with our favorite topic, one of the subunit of number system, which is called bond and error intervals. And as we all know that we are going to talk about bonds. What are bonds? From the last topic that we learned, we talked about bonds. We said bounds are the values that a rounded number can lie between. Okay, so we said in bonds we have lower bond and upper bond. There are two types of bonds. We have two types of bonds. We have the lower bond and number one, and number two we have the upper bond. So we have the lower bond and the upper bond. The lower bond, what is the lower bond? We say the lower bond is the smallest value that a number can take, and then so we say the smallest value that a number can take, it be abbreviated as LB, and we have the upper bond, which is say the largest value that a number must be less than, or yeah, we can say that a number must be less than. For example, this is the upper bond. Very good. So we say the lower bond is the smallest value that a number can take, and the largest, we say the upper bond is the largest value that a number must be less than. So if you refer back to our notes. And then how do we find the upper and lower bond for a rounded number? This is the secret. Also, we did it in the previous class, and we're going back. So what we're supposed to do, we say, how do we find the upper and lower bound for a rounded number? Now, provided you're given a number, we said, first thing foremost, we say, how do we find the LB and UB, which is LB stands for lower bound and UB stands for upper bound for rounded numbers. Correct. Number one. So number one, we say identify the degree of accuracy to which the number has been rounded. Perfect. So we need to identify the degree. We need to identify the degree of accuracy, to which a number has been rounded. For instance, you have let's say we have a number, e.g. we have 36,400, and then has been rounded to the nearest 100. Correct. Then say divide the degree of accuracy by 2. Now, for example, we have the number 36,400, which has been rounded to the nearest 100. So we identify the degree of accuracy to which a number has been rounded. And then rule number 2, we say divide the degree of accuracy. So we divide the degree of accuracy. If we divide the degree of accuracy, what exactly we are going to get here? If we divide the degree of accuracy by 2, we are going to get the limit, which you are going to either add or subtract from the number given. So for instance, here we have, so we say e.g. if an answer has been rounded to the nearest 100, half the value is, so if the number has been rounded to the nearest 100, so 100 divided by 2, you get 50. Now, rule number 3, in the rule number 3, we say, add this value to the number to find the upper bound. Yes, so when we add this value to the number to find the upper bound. Correct. For instance, we have, let's say we have 36,400 plus 50. What do we get? We get 36,450. Correct. Then subtract this value from the number to find the LB, which is the lower bound. E.g., so we have 36,400 minus 50, you will get 36,350. Correct. Then we say, so the error interval. What's the error interval? Now, the error interval, we say, is the range between the upper and lower bound. So the error intervals falls, we say the error interval is the range between the upper and the lower bounds. So there are two, between the upper and the lower bounds. So error intervals, so we can say now, therefore, error intervals is equal to LB is less than or equal to X, which is less than UB. Correct. And now your answer here, we know the lower bound is 36,350 is less than or equal to X, and X is less than 36,450. This is our answer, and that's what you need to do. Now we have some good examples of questions. Our example, how do we find the lower bound and upper bound of whole numbers? For example, what is the lower bound and upper bound of the following? So A, we have 37. What is the lower bound and upper bound of the following? 37. So obviously, you will say 37 is a number there. So we have, it's a whole number. A whole number, so we say, what's the lower bound and upper bound? So we say its limit, you'll get the limit by just taking a whole number divided by 2, which is 0.5. So to get the lower bound, you'll take the number, actual number 37 minus 0.5. And then to get the upper bound, you take 37 plus 0.5. So this you get 36.5, and this one you get 37.5. Now, how do we find error interval? The error interval. This is mostly asked question in IGCSE question. So error interval is, lower bound is less than or equal to X, and the upper bound is less than the actual number. Yeah, that's nice. So then our lower bound is 36.5 is less than or equal to X, and X is less than 37.5. Correct. This is what you can be able to do. And then we go to the next question. Next question is, let's say 5. You have a 5. 5 is a whole number. All whole numbers, to get their limit, you just take 1 divided by 2, as long as it's a whole number, and you get it 0.5. And then after getting that 0.5, to get the lower bound, it's simple. The lower bound is equal to the number, which is 5, minus 0.5. You get 4.5. To get the upper bound, you just take the number 5 plus 0.5, which is the limit, and then you get 5.5. Error interval. The error interval. As we know, error intervals falls behind, we say it's LB is less than or equal to X, and X is less than UB. Correct. And now you can write LB. What's LB? 4.5 is less than or equal to X, and X is less than 5.5. That's what you do. Now, another thing, candidate, you might ask yourself, what if now, in the same scenario, I'm supposed to find upper bound and lower bound of decimal numbers? What am I supposed to know? Now, you need to just find the degree of accuracy. Okay, my degree of accuracy, if let's say, for example, I have 5.6. My degree of accuracy, remember here, is 10th. So 10th is my degree of accuracy. So 10th is 0.1. Now you have 5.6. How do I get the degree of accuracy here in this scenario? The degree of accuracy here is 10th, 0.1. So take 0.1, divide by 2. What do you get? You get 0.05, which is different from a whole number, right? So then you say, I need to find now the UB. This is my limit. My limit is 0.05. I need to find the upper bound. You can only get the upper bound by adding the number 5.6 plus 0.05. And then what do you get? You get 5.65. And then the lower bound, you will take the actual number 5.6 minus 0.05. And then what do you get in that scenario? You will get if you do that, you get 5.55. Yeah. So if you do that, yeah, that's what you get. Then you say error interval, and error interval falls behind lower bound is less than or equal to x, and x is less than UB. Correct. Now, in that scenario, the lower bound, what's our lower bound? Our lower bound is 5. Lower bound is 5.55 is less than or equal to x, which is less than 5.65. Correct. That's it. Okay, what if I have a larger number, which is, let's say you have 78.73. Let me say if that's a scenario. Now I have this number and I'm supposed to find its upper bound and lower bound. Obviously, the first thing that we need to do, dear candidate, if you're expecting to do an IGCSE exam, what you're supposed to do to find the degree of accuracy. What is your degree of accuracy in this scenario? Find the degree of accuracy. The degree of accuracy in this case, find the place value of 3, which is, remember, tenths. After the decimal, we start with tenths, hundredths. Now, the degree of accuracy is 100, means 0.01. Hundreds mean 1 out of 100. Divide by 2 to get the limit. Therefore, obviously, if you do that, even in your calculator, you get 0.005. Yeah, if you do that, you get that. Then, what do you do? What do you need to do then? After that, then that means our upper bound, which is you take the number 78.73 plus 0.05, 78.735, and then your lower bound is equal to 78.73 minus 0.005, which is 78.725. Therefore, error intervals falls behind the lower bound is less than or equal to x, and x is less than UB. Therefore, lower bound will be 78.725 is less than or equal to x, which is less than 78.735. Correct. Now, what basically is normally tested in IGCSE? We have this kind of questions. So I'll go basically to this question. This question says Claudine cycled the distance of 53 kilometers in 2.7 hours. The distance is measured correctly to the nearest kilometer. The time is given correct to 1 decimal place. Calculate the lower bound and upper bound of her average speed. Give your answer correct to 2 decimal place. So this is it's a 6 marks question, mind you. This is a IGCSE question. So it says, what did Claudine did? Claudine cycled a distance of, so this one cycled, the cyclist cycled a distance of 53 kilometer in 2.7 hours. Correct. So the distance is measured correct to the nearest. So we have the distance is measured correct to the nearest kilometer, and the time is given correct, and the time is given correct to the nearest. The time is given to the nearest. The time is given to the correct to nearest 1 decimal place. yes, and the time is given correct to 1 decimal place. Give your answer correct to 2 decimal place. So by calculate the lower and upper bound of her average speed. Now this is a different scenario. Here they're asking calculate the lower and upper bound of her average speed. So average speed, the formula for finding speed we know, or finding average speed. The formula is always distance divided by time. Now, in what cases are we able to find the lower bound? Now, this is where the IGCSE, this is where now the IGCSE examiner's tricks put. You can fail this question. It's the way is as simple as it is. Because if you take the just, okay, now you say to the nearest kilometer, this will be 53.5, my upper bound, so 53.5 divided by what is my time? My time is 2.7, so the degree of accuracy is 0.1 divided by 2. So the first fun thing, we need to find degree of accuracy for each. Degree of accuracy. Identify the degree of accuracy for each. For the first one, for distance, we obviously know. For distance will be 1 degree of accuracy. So that means we will take a whole number 1 divided by 2, you get 0.5. So distance, correct. Then the degree of accuracy for time, obviously it's a decimal, so it's 0.1 divided by 2. So if you 0.1 divided by 2, what do you get? 0.05. Correct. Perfect. So that's for time. Now, this is in hours. 0.05 hours. Okay. Now, in what scenario are we able to get the upper bound? So we can get the, because they say calculate the lower and upper bound of her average speed. So we say the lower average speed can only be gotten by, you can only get, say, to find the upper and lower bound of the distance. So the bound for distance, the upper bound, what is our upper bound? Upper bound will be, obviously be 53 kilometer minus plus 0.5, which is 53.5 kilometer. And then the lower bound will obviously be 53 minus 0.5. If you do that, what do you get? You get 52.5. Correct. You get 52.5 kilometer. So we have 52.5 kilometer and 53.5 kilometer as our upper bound. Okay, lower bound is that. Then we say to find the lower bound of time, we obviously know the lower bound of time. So our degree of accuracy is 0.1. Then divide by 2, you get 0.05 hours. Therefore, for time, so the above was for distance. For time, we say the upper bound time will be, obviously, the time taken was 2.7. So 2.7 plus 0.05, which will be 2.75 hours. And then the lower bound will be 2.7 minus 0.05, which will be equal to 2.65 hours. Correct. Then we know the formula now. We understand now the formula. Our formula here, speed is equal to distance over time, d over time. Now, to find the smallest possible speed, what do we need to do? It means to find the smallest possible speed, you need to use the smallest possible distance and the largest possible time. That's where the trick is, dear candidate. To find the smallest average speed, you need to find what? You need to find the smallest possible distance with the largest possible time. Therefore, we'll take the smallest possible distance, which is 52.5 kilometer, divide by the time, the longest time taken, 2.75. That's it. And then what you get there, divide using your calculator, you get 19.09 kilometer per hour. That's it. And then to find the largest possible speed, you need to use the largest possible distance and the smallest possible time. To find the largest possible speed, you need to use the largest possible distance and the smallest possible time. So we have 53.5, which is the largest distance, and the smallest correct time. Yeah? And the smallest possible time. So you divide that, you get 20.1886. kilometer per hour. Yeah, that's the scenario. You can have this kind of questions. It's 6 marks. So that's also one of the mostly asked questions in IGCSE Math. So you'll get this kind of scenarios whereby you are asked to show the deeper understanding of this concept. Like how do you get some answers using those scenarios without any complaint. That's majority of questions. Like majority of the questions, you will see them. They will be in that format, like upper bound, lower bound, but mixed up. So you won't even understand sometimes what they're asking. But obviously, with that understanding, you'll be able to know what they ask. Another example, you say Anna walks 31 kilometer at a speed of 5 kilometer per hour. Both values are correct to the nearest whole number. Okay, both values are correct to the nearest whole number. So our degree of accuracy is nearest whole number. So that means 1 divided by 2, which is 0.5. Correct. So both values are correct to the nearest whole number. Work out the upper bound of the time taken for Anna to walk. So work out the upper bound of the time taken. So Anna walks 31 kilometer at a speed of 5 kilometers. That's it. So distance is 31 kilometer. Time is time we don't know. Speed is 5 kilometer per hour. So we know speed is equal to distance over time. If we need time, it's distance over speed. Now here our distance is 31, speed is 5. 31 divided by 5, what do we get? Now work out the upper bound of the time. Now we cannot get this. So to get the upper bound of the time, what do we need to do? That's where the mistake also majority of the students do. So here in this case, before we solve this kind of question, we need to do this. Before we solve this kind of questions, before we go here, we know that the formula is, we understand that the formula here is distance, time is equal to this d over s. We know that time is equal to d over s, distance over s. So what, distance over speed. So what do we need to do? We need to get the upper bound of distance. We need to because we know now the limit is 0.5. So distance upper bound will be equal to 31 plus 0.5, which is 31.5 kilometer. And then the lower bound, will be 31 minus 0.5, which will be 31 minus 0.5. Let's do some separation there. 31 minus 0.5, it will be 30.5, correct? 30.5 kilometer. And then for speed, upper bound, so we say lower bound of speed is equal to 5 minus 0.5, which is 4.5 kilometer per hour. And then upper bound of speed is 5 plus 0.5, which is 5.5 kilometer per hour. Now, the question says, work out the upper bound of the time taken for Anna's walk. If we need the upper bound of the time, that means we need to use to take distance, because we now know time taken is equal to distance divided by speed. We'll take our upper bound distance, which is 31.5 kilometer, divide by our speed, which now we are going to use our lower bound speed, 4.5 kilometer per hour, so that we can be able to get our upper bound of time taken. That's where the examiner's trick is. So we remain on with only hours. If you divide that, you will get 7 hours. Correct. These are different kind of questions that can come in your IGCSE exam. Dear candidate, they are not hard, but they just want you to basically understand what is being questioned. Thank you.